Hello everyone, I'm Zhiheng Fu from the University of Western Australia. Today I'd like to introduce our new work VAPCNet, Viewpoint-Aware 3D point cloud completion. First is the background and motivation. Currently, LiDAR and Kinect can only recover the single-view 3D structures. Point cloud object completion aims to recover the full shape of objects. They can be used for object grasping and obstacle. This is an overview of the point cloud object completion. Normally, given the input incomplete point cloud, the encoder-decoder structure is designed to achieve point cloud completion. For the encoder, PointNet, PointNet plus bus, and their variants are widely used to extract useful information from input incomplete point cloud. For the decoder, attention mechanism such as skip attention is used to recover the detailed complete point cloud. However, the viewpoint information is seldomly considered in the field now. It is a fact that complete objects can be composed of visible parts and missing parts. Moreover, the visible parts are closely related to corresponding viewpoints and can vary a lot when obtained from different viewpoints. Thus, we try to explore the effective needs of viewpoint information for point cloud completion. Next, I will introduce the proposed method. As I mentioned above, we think that viewpoint information is very important for point cloud completion. However, explicit viewpoint estimation is usually time-consuming and leads to huge annotation cost. Motivated by the recent advances in contrastive learning, we propose to use unsupervised viewpoint representation learning by contrasting positive pairs with negative pairs within the latent space, thereby generating a distinct latent representation for each incomplete object. These are the visualized results for the unsupervised viewpoint representation learning. From this figure, we can see that 26 partial objects scanned from different viewpoints are represented into different viewpoint representations. This is an overview of the proposed VAPCNet. For the viewpoint encoder, we pre-train it using contrastive learning. After getting the viewpoint representations, next, I will introduce how to effectively use them. We use the seed generator to predict the coarse complete point cloud, and then we hierarchically fed the viewpoint representation to the designed upsample and refinement module to achieve point cloud upsampling. For the upsample and refinement module, we use the fuzziest point sampling and linear interpolation methods to upsample point cloud and the corresponding point-wise features respectively. Then, we use the designed viewpoint-aware module to achieve refinement. The figure D shows the detailed structure of the proposed viewpoint-aware module. In this module, the viewpoint representation is fed to two branches. In the first branch, it's used to predict the kernel of a depth-wise convolution. In the second branch, it's used to learn modulated parameters for self-attention to automatically aggregate local information for each point. In this way, the viewpoint representation is effectively used in enhancing shape completion. Finally, I will introduce the experimental results. In the point cloud object completion field, MVP and PCN datasets are widely used. Chamfer distance and F1 score are widely used evaluation metrics. These two tables show the results on MVP dataset in terms of chamfer distance and F1 score for all categories. We can see that the proposed method outperforms all the previous methods for all categories. To further explore the effectiveness of proposed method, we also conducted multi-resolution shape completion experiments. From Table 3, we can see that the proposed method outperforms previous SOTAs in all resolutions. In Figure 3, we show the visualized results on the MVP dataset, and we can conclude that the proposed method can recover better complete shapes than other methods. From Table 4, we can see that the proposed method achieves comparable performance to the snowflake net in the category of cabinet and car. For other categories, the proposed method outperforms other methods. In Table 4, we show the visualized results on PCN dataset, and we can conclude that the proposed method can recover better complete shapes than other methods. To demonstrate the effectiveness of proposed modules, we conduct the evaluation studies. From Table 5, we can conclude that the proposed modules can boost point cloud completion.